we have a particle that moves along a curve given by x, y, and z. We need to determine the velocity and acceleration at any given time and calculate the magnitude at a specific time of t equals to 0. So let us begin. So since our particle is moving along this curve, that means the position vector at any given moment of time t will be specified as x times I cap plus y times j cap plus z times k cap. That means we have e raised to the power of negative t I cap plus 2 times cosine of 3t j cap plus the z component. So that will be 2 sine 3t k cap. So we have our position vector. To find out the vector, all we have to do is take the first derivative of our position vector with respect to the time or the scalar parameter t. So we will take the derivative of each of the terms on the right hand side of equation number 1. However, I cap, j cap, k cap are constant vectors, so that means the time derivative of each of the unit vectors will be equals to 0. So this goes true for the j cap and k cap unit vectors as well. We will use that fact. Now we will only have to take the derivative of the respective components. So derivative of e raised to the power of negative t will be negative e raised to the power of negative t I cap plus derivative of 2 times cosine of 3t. So we have negative 6 sine 3t. So here 2 have to get multiplied with 3 as a consequence of the chain rule, and derivative of the cosine function is negative sine function. So this is j cap plus derivative of 2 sine 3t will be 6 cosine of 3t j cap. So this is equation number 2, which is the expression for our velocity vector. Then finally we find out the acceleration vector. So to find out the acceleration vector, we take the time derivative of our velocity vector. Same way, we will take the derivative with respect to t of each of their components. So derivative of negative e raised to the power of negative t will be positive e raised to the power of negative t I cap plus derivative of negative 6 sine 3t will become negative 18 cosine of 3t j cap plus derivative of 6 cosine of 3t will be negative 18 sine 3t k cap number 3. So we have obtained the velocity and acceleration at any instant of time. So these are the two expressions. Now we have to find out the magnitude at t equals to 0. So let's find out the magnitude of velocity and the magnitude of acceleration. First, we'll begin by taking the magnitude of velocity. All we have to do is we'll have to take the square root, and underneath the square root, we'll take each of the components and square it. So squaring negative e raised to the power of negative t will give us e raised to the power of negative 2t. Plus, we'll add them with the square of the other two components. So we have negative 6 sine 3t, so its square will be 36 sine squared 3t plus 36 cosine squared 3t. Right. Now, we have e raised to the power of 2t. Now, if we take 36 as the common factor, so this 36 will get multiplied to sine squared 3t plus cosine squared 3t, which is a constant, which is identity with a value of 1. So we have 36. So this is the magnitude of the velocity. Now we want to calculate its magnitude at t equals to 0. So that means the velocity at t equals to 0 will be equals to, we have the square root of e raised to the power of 0 plus 36. E raised to the power of 0 will be 1. So this will be square root of 37. Similarly, we'll try to find out the magnitude of our acceleration vector. The magnitude of acceleration vector will be, we'll take the square root, square each of their components and add them to each other. So this will leave us with e raised to the power of negative 2t plus 18 squared. So at t equals to 0, our magnitude of our acceleration will be, we'll have 1 plus 18 squared, which is equals to approximately 18.03. And for the velocity, we had square root of 37, so its value is approximately 6.08 unit per time, and this will be unit per time squared.